just brush my hair for a moment. And let's see. I'm trying to think how I want to explain it. I'm going to reload chat, so I might miss something if someone says something right at this instant, which for you is while in the past. No, the few, yeah, a while in the past. It's like the pre-taped call-in show on Mr. Show, trying to think that through. I'll wait till, let's say 30 viewers. Although they only update that count. I don't know how often they've done the count. Because we were up to 40 something before I stopped, so I figure. Because the explaining is kind of, I think, going to be the interesting part of this. The most educational part of this. I mean, I don't know, the programming is obviously always educational, but yeah, when I clear the chat, I should just type that in chat rather than worrying about the video delay. What else can I do to kill time? Yes, I did see the new Mr. Show episodes. Yes, I did see the new Mr. Show episodes. I felt like they weren't as good, but, you know, colored hindsight and stuff. I think the consensus among my peer group was there was the one episode that was really strong. That was the episode with David Cross being the... they had that sketch with David Cross being the guy obsessed with freedom and trying to get the police stop, trying to get them to abuse their authority. That sketch and a couple other sketches in that episode I think were really strong. Okay, it's up to 27, so I guess that's good enough. So what I want to do is explain what the goal is, how we do it currently, and how I'm going to change it, and then why that change shouldn't be so bad. So when I make the proposal, I'm just going to propose what I think is the right thing, as opposed to the easy thing. But I think it turns out to be easy, too. Well, it obviously turns out to be easy from first principles. Like, if we were just writing from scratch, it would be like, that's a simple way to do it. But I think it's also going to be a simple change. So all of these things are good. And of course, I stare at the code when I'm explaining all this stuff, and I'm talking to you, and I should probably talk to the camera, but whatever. It's such a far away turn. I mean, it's where I look when I'm looking at chat, kind of. But all right, so, and there'll be a quiz at the end on what the list of things I just said I was going to say are. That quiz being that I'll get to that. I'll get through some of that and then forget that I wanted to say some of those things, and somebody has to remind me. I went to say all 4 of those things. All right, so what is the problem that we're trying to solve? When we go render, I'm not going to try to go from 100% first principles, but when we go to render, we want to render these chunks around us, these meshes. The world has been divided into chunks that are meshes, a bunch of 3D geometry that we render. And this is all procedurally generated, and it takes time to do it, so you can't just do it. You can't just generate the data that you need to render as you're rendering. So we want some kind of system whereby the renderer, or somebody, in this case it's the renderer, we could do it a different way, decides what things it wants to render. And then there's some system that's responsible for background tasks. Right? But currently we're calling this job system or whatever, but this is called the background task system. And the renderer wants to tell the background task system, background job system, what stuff it needs that it doesn't have, so that it can get generated in the background. That's the statement principle. And then there needs to be some kind of system in the background getting the work done. And we have constraints. We obviously have correctness as a constraint always, and performance as a constraint. That's why we're bothering to do a system with threads at all. It's for performance. There's a version of this where we just, every frame you can at most generate one mesh or something like that. And so that it evens out the workload, keeps from being too slow in the main thread. But that system doesn't even work when I last tried to turn on. Okay. So what the current implementation does is the renderer what the current implementation work when I last tried to turn on. Okay. So what the current implementation does is the renderer, in the single thread one, it actually does it while it's rendering. But in the current version, in the multi-threaded case with the background work, it doesn't try to actually do it as it's rendering. Right before it goes to render, it just traverses the entire directions all around the player out to some distance and says, these are all the meshes I need. And it checks, I believe, which of those meshes already exist. And if they do already exist in its cache, then it ignores them. And if they don't exist, so here we get it from the mesh cache. So if there's nothing in there, or if it's the wrong thing in that slot, or if it's been flagged as dirty. Why do we have that? That seems wrong. Oh, even if it's an empty vertex buffer, we must put something in there. Okay. So if it's the wrong one, or if it needs updating, then we add it to this list. So the only thing that goes into this list are the things that need updating, or the things that don't exist yet from the renderer's perspective. That list is huge. Because at the startup time, nothing exists, so we have to traverse all the stuff around you. And by making it huge, the order we traverse them doesn't actually matter. So we can just traverse them in order, so we just traverse them in raster scan order. And we're just assuming that the mesh will never fill up. In fact, we don't ever actually test that here. Then we sort them into the priority order, where the priority is just the distance from the camera. And then we start building the actual list. And it also includes some meshes that we need for physics. And then we just go through in priority order and add them to this list. So this list ends up containing all of the meshes that the physics needs but doesn't have, and all of the meshes that the renderer needs but doesn't have. We take that whole list, all of the meshes priority order. It also includes some meshes that we need for physics. And then we just go through in priority order and add them to this list. So this list ends up containing all of the meshes that the physics needs but doesn't have, and all of the meshes that the renderer needs but doesn't have. We take that whole list and we call swap requested meshes. And we got this from the job system. We told the job system, give us the list that we're going to fill out. And then here we tell it, okay, we filled it out. The naming is not perhaps very good, as it's exposing the functionality. Okay. What does the job system do with this? What does the job system do? Okay. Exposing the functionality. Okay. What does the job system do with this? Ignoring the bugginess. What it does is it keeps... So the way the generation works is that for various arcane reasons, the procedural generator works on a different scale than the mesh generator. It uses a different size chunk. and the same chunk actually gets used by multiple meshes. So there are 3 or 4 systems in play at this point. One system is responsible for keeping track of what work has gotten done so far on a mesh, and that's the mesh chunk status. So the job of that is just to keep track of what work we've gotten done on this mesh so far. There is also, not visible here, a thing for the procgen status, because we're generating different size chunks for the procgens. So a separate data structure is a cache of the chunks that we've generated from the procgen, because they do get shared by multiple things. So when you generate a procgen thing, you stick it into this cache, and then another thing goes through and looks at the mesh chunk status and says, oh, this chunk is gen chunk is available now, I'll add it to my mesh chunk status. So this thing is responsible for accumulating all of the gen chunks that it needs. But I'm jumping ahead of myself a little here. Almost none of this is historical reasons. This is pretty much just, I couldn't figure out how else to do it. Almost all of the things I've described so far are going to be unchanged in the new system. I think the new system is going to be simpler, but I'll get into the details of that at step 4, since this is only step 2. Almost none of this is historical reasons. This is pretty much just, I couldn't figure out how else to do it. Almost all of the things I've described so far are going to be unchanged in the new system. I think the new system is going to be simpler, but I'll get into the details of that at step 4, since this is only step 2. I'm kind of getting ahead of myself here because this phase just goes through and says, have I started building the mesh, doing the final processing step for any of these things? If so, delete it from this list. That was what I was just starting to work on at the end of the last thing, the handling of that. Because if it's already started on the final step, I'm kind of getting ahead of myself here because this phase just goes through and says, have I started building the mesh, doing the final processing step for any of these things? If so, delete it from this list. That was what I was just starting to work on at the end of the last thing, the handling of that. Because if it's already started on the final step, that's never abortable. That's going to finish no matter what. So we don't care about it. But the other thing it does is it's like, if the renderer no longer asks for a mesh, then this system wants to abandon any of the work that it's already done on that. So that's this abandoned thing here. So there's a mesh that's partly done, but it's not in the list that the renderer just handed to it. We need to abandon it. And that's still true in the new system. We're going to have to do something like that. So a lot of this complexity is unavoidable, I think, given the constraints. This would be so much simpler if we could procgen. So a lot of this complexity is unavoidable, I think, given the constraints. This would be so much simpler if we could procgen exactly the data we needed for each mesh, because then there would just be one task. You come in, you say, here's the mesh because then there would just be one task. If we could procgen, so a lot of this complexity is unavoidable, I think, given the constraints. This would be so much simpler if we could procgen exactly the data we needed for each mesh, because then there would just be one task. You come in, you say, here's the mesh here's the chunk of the area that I need. Procgen it, mesh gen it, all in one job, all in one thread. All this complexity would go away. And maybe someday I'll try to rewrite it that way. But today is not that day. So that's what happens at this. So that's what happens at this first phase of processing it. We discard work that's in progress. So a lot of this complexity is unavoidable, I think, given the constraints. This would be so much simpler if we could proc gen exactly the data we needed for each mesh, because then there would just be one task. You come in, you say, here's the mesh here's the chunk of the area that I need. Proc gen it, mesh gen it, all in one job, all in one thread. All this complexity would go away. And maybe someday I'll try to rewrite it that way. But today is not that day. So that's what happens at this first phase of processing it. We discard work that's in progress that's no longer needed, and we build a sort of a final list. And then we switch to this manager thread. So the manager thread is basically, when I get this list, especially at the very beginning, it's got all of these chunks in it that I have to traverse. There's a lot of stuff there. And so processing that is expensive. And so I was like, well, I mean, this is sort of implicit. Like, this is the justification for it. And now that I think this is the wrong way to do it, you know, I can't offer the justification very well. But the idea is that in going through the list in one pass, traversing the list and checking the status of everything and updating the status of everything, you can decide what new work to do in order, because this list is in the priority order. So you can decide all the work that you need to do. And so you might as well cache that. And partly it's because, like, when you have tasks and jobs and stuff like that, your thoughts very naturally go to things like thread safe queues, because, you know, a thread safe queue is sort of like a common, obvious way. It's sort of best principles of how to do this stuff. I had to roll my own thread safe queue, so it wasn't like, you know, whatever. But it's kind of a best principles thing is probably why I went there. So this thing analyzes that whole list. It decides what work needs to get done to get each thing done, and you know, updates the thread safe queues with the needed work, and then goes to sleep. Basically waits till either the next frame and the renderer says, oh, I've got a new list for you, or if it gets woken up by when one of the tasks finishes and it needs to update its list. But conceptually, it's able to, you know, if it takes less than a frame to do a single proc gen step, then, you know, a thread is going to, a worker thread is going to process multiple entries from the queue. So we, in one pass through the whole list, we're able to generate a bunch of entries into the queue for all the workers to do. That's sort of the logic of that. I don't think I need to go into more detail on this, but if what I just said doesn't make sense, let me know, and I'll do a little bit more, because I'm about to now launch into how the new system is going to work, which is step 3. And so then the worker threads are very simple. They just get a task off one of the task queues and execute it. And when they finish it, they update the status and they wake the manager thread to have it figure out what to do next. Okay, I can see in the stream. Okay, I can see in the stream that I am past where I asked for questions. I don't see any questions. So, here we go. Short explanation for why they operate on different chunks. Short explanation for why they operate on different chunk sizes. Yes, I've explained this many times in the thing, but I have no problem explaining it again. So, there are two, maybe there are 3 reasons. Okay, but the primary reason is that at the edge of a chunk, like what you could do in a voxel engine is you can actually slice the world up into chunks and independently build every chunk totally independent of every other chunk. But if you did this at the boundaries between the chunks, So one of the things you do in a voxel engine to really push your polygon count is, each block is 6 quads, right? And you stack them up and you make these big piles of them. You don't actually draw the polygons that are hidden, right? The polygons that are pushed up against another solid block, it can never be seen, so you delete it. And that's actually what STV voxel render really, that's all it does. It provides you some clever shaders, a clever packing of the data that's into the shaders, but its main task is to produce the polygon data that's fed into those shaders, and it does this hiding of the intermediate things. So if you split everything into chunks, then at the chunk boundaries, you don't know what the data is outside of the chunk boundary. And much as you could draw every block in a voxel renderer by drawing all 6 faces, you can still do that. You can, at the chunk boundaries, just pretend what's beyond that chunk is air, and which causes it to build all the surfaces on the outsides. You could do that, and when you render it, you'd have these hidden faces at the chunk boundaries, and it would all render exactly the same. But you would be pushing a whole bunch of extra polygons. And I don't know what the count is, but like if you imagine a really simple flat terrain, Minecraft will have tons of caves and stuff underground. If you imagine a really simple flat terrain, the surface, about a 16 by 16 chunk, let's say, that's 256 quads on the, if it's a flat terrain, 256 quads on the surface, relatively flat, maybe it's 512 quads or something like that. But now if the ground extends underground, if you're building at height, it's 64 in Minecraft, at 64 quads down, 16 wide, so each side of each chunk, you're going to be spending 16 times 64, so 2 to the 6 plus 2 to the 4, so 1,000. So you'd have 256 quads on the top and 1,000 on each side. So you'd have 4,000 on the sides and 256 on the top. So that's not a recommended way of dealing with chunks. Somebody might do it that way. It's possible. If you do, that simplifies things because you don't have to worry about that. So instead, what you need to do with STB voxel render is you could do it that way with STB. What I do in all of my STB voxel render style stuff, and what it's designed to support, is that you pass in one extra row of blocks around your chunk, so that it knows how it's going to do it. And that means that the areas that it works on when it's doing each consecutive mesh next to each other overlaps. There's a 2-block overlap along that seam, 1 block on each side. So when you go to make the mesh, you need to get at that data somehow. And if you're Minecraft style and all the data is streaming in from disk, of course it's procedure generated, but you could just stream it all out to disk and then stream it in from disk. It just means you need some system to let you pull that in from disk in some way to make that work with that overlapping. When you're proc gen based, one thing you could do is proc gen a little extra data, right? You just, okay, so I need my chunk to be 16 by 16 for rendering, so I need to generate an 18 by 18 chunk in the proc gen system. There's a couple different strategies for doing proc gen, and the proc gen strategy I'm doing basically treats the border. I don't actually know if I'm doing it much in this system, but the general scheme basically treats the borders between chunks as special, and knows some extra info about how to generate a 1-block wide region on it. And I never really thought this through, but if I did design that system so it could generate a 2-block wide thing, that would actually work. But it only is 1 block wide. And so then what that means is that if you wanted to generate a little bit of bigger data in the procgen stuff, it's really complicated, because instead of the procgen thing being designed around, I'm building a 16 by 16 region, and the edges of that 16 by 16 region are special, it's now I'm building an 18 by 18 region and the strips along just short of the edges are special. And then the data just past that, the one more row past that, depends on a bunch of state that's even further out. And you start having to generate a lot of extra superstructure state to know how to generate the data. And if you restrict what you're procgenning to just lie inside these well-defined chunks that don't overlap, you can avoid that. That's sort of the concept. I have no good advice for programming because I've been doing it for too long, so I don't really know what to do at the beginning. So then there are some more reasons why the chunk sizes are different. So the chunk sizes are different. And there are some more reasons. So then there are some more reasons why the chunk sizes are different. So the actual mesh chunk size is 128 by 128. I forget, 64 by 64. Mesh chunk size 64 by 64. And the gen chunk size is 32 by 32. And the idea there is that if the gen chunk size were 64 by 64, then it would exactly match the mesh, but I would need all the neighbors. You don't actually need the diagonal neighbors. I think I'm doing the diagonal neighbors and I don't need them. I think I'm doing the diagonal neighbors here and I don't need them. When would you need the diagonal neighbor? That's an interesting thought. Let me write that down in the to-do real quick so I don't forget. Let me write that down in the to-do real quick so I don't forget. Okay, so pretending that I had not thought of that. So the question becomes how much work. So the question thought of that. Pretending that I had not thought of that. So the question becomes how much work do you have to do to build a single mesh? And the answer is, if ignoring that, if they were the same size, you would have to build a 64 by 64 proc gen region that the map is, and then you'd have to generate 64 by 64s, etc. You end up generating 192 by 192 of data, even though you only needed 66 by 66. And if you could make the proc gen system smarter and only being able to generate little strips, maybe you could get some speed up there. But that's extra complexity in places that don't need the extra complexity. So instead I made him 64 by 64 for the mesh and 32 by 32 for the gen chunks. And that means it takes 4 gen chunks to fill in the things and then 12 more around the outsides. But it only takes, the total size that you're doing then is 32, is 128 by 128 instead of 192 by 192. So you generate less data. And then finally, for the physics, when we generate this procedural data, we then turn it into polygon meshes and throw away the byte per voxel data that we just generated. We just turn them into meshes and throw them away. Well, we cache them so in case we need them for other purposes, but the cache, as you're rendering, since you're rendering out in the distance, we're keeping a little physics description around the player that's relatively small area. And so when you move the player, you need to know the new physics state over here, and that's not going to be available in the render cache, which is storing meshes far in the distance often, because of those are ones being processed by the renderer. So to update this physics thing, you need to run the procgen, but you don't need to run the mesher. So it just needs a single procgen thing. And so keeping that on a smaller size just makes the physics a little more efficient to update. Okay. So the new scheme. I still have to do almost all of the things that I talked about. I still need to keep track of what work is in progress. I still need to abandon work that's no longer needed. So a lot of those things stay the same. What's changing is how all the threads work. Here's the observation. In one pass through, the renderer supplies us with the request list. And the manager makes a pass through that list, the whole list, and says, here are some things that, and the list is in priority order, so the manager goes through and says, here's the work that needs to get done next from going through this, and updates a bunch of queues, of thread safe queues with tasks. And we were just saying that the problem is that those thread safe queues can't get reordered. And we would have to augment them with something to reorder them. And that just seems like a lot of extra complexity, and there's a lot of extra lists. And I made a comment that conceptually what needs to happen is that each thread just, at the moment when the thread goes to do the work, we could, God's eye view, go, here is the highest priority thing for you to do at this instant. Looking at the state of the whole system, here's the highest priority thing to do, and you should go do that. And this whole system totally obfuscates that. Now, we'll never get to God's eye view. The God's eye view of the system is like, the renderer has started asking for this thing, so that's the most important one, but it hasn't gotten through the swap stuff, so there's no way for this system to know that. But, we can just say what happens if we just code every thread to go, let me go find out what the highest priority piece of work is. What's the biggest principle about optimization? It'll take a little while for that to cycle through the Twitch lag. Let's wait for the answer though, because I think everyone should. Most people who follow this stream should have heard this principle, not by me, by other people. To a certain extent, I maybe eschew this principle a lot of the time. Certainly when I was in my 20s, wearing a looking glass, I eschewed this principle. If you don't remember the biggest principle of optimization, I'll accept the biggest rule for optimization. Assume nothing. Let me answer this in chat. Someone asked, why not run the manager code on the main? Let me answer this in chat. Assume nothing. Assume nothing. Let me answer this in chat. Someone asked, why not run the manager code on the main? Someone asked, why not run the manager code on the main thread? You could do that. I just figured that was some work. Why not fork it out into another thread? Like, let's keep as much as we can off the main thread if we're doing the background work. That could be done. It wouldn't actually address some of the issues that we're having here with the thread safe queues not being reorderable. So assume nothing is more. It's more like the biggest rule. I think the biggest rule is traditionally measure before you optimize. That's what I would. So assume nothing is more. It's more like the biggest rule. I think the biggest rule is traditionally measure before you optimize. That's what I would sort of call the primary role of optimization. And there's a principle. And I'm using those terms pretty arbitrarily, that is frequently cited, that is sort of the corollary of that, or, one of them, neither of them quite implies the other, but they are strongly related. It's the only thing anyone ever says about optimization when they're talking abstractly. It's the only thing that exists as a canard. That's about optimization. So I will say it in a second if nobody... There it is. There's the... Nobody... There it is. Say it in a second if nobody... There it is. There... Nobody... There it is. So I will say it in a second if nobody... There it is. There's the... Someone has typed a single word. Premature. Yes, premature optimization. So you can argue that all this stuff that I did with this worker manager was premature optimization. Stuff that I did with you can argue you can argue that all this stuff that I did with this worker manager was premature optimization. The idea that each thread could figure out for itself what to do kind of implies each thread running all of this code that the worker thread runs. And that's inefficient. And, you know, I talked about the idea that in one pass through it, you can figure out a whole bunch of things that it can do that need doing, and build those other lists that are threads at queues that are sort of best practices. And so that all seemed like a reasonable way to do it. We're used to thinking about job systems that really try to optimize for making the, you know, the job stuff fast, trying to make things go making things go I read chat and I lost what sentence I was in the middle of. Yeah, I totally have no idea where I was in that now. And I'm trying to figure out where to restart from. And now it's been long enough, maybe somebody in chat will remind me where I was. Right. I was talking about the premature optimization. So I was saying that can process a lot. So it can gather a lot of info in that pass through it. And the list is potentially very long. The list of requested threads, because when, for example, at startup or after teleportation, or if, you know, you have multiple players and they all change things throughout the world at the same time, you can get big lists. Like there's definitely, the list can be long. It's not like just a special property of the startup time. We definitely have to handle the case that the list is long. However, I think it's a mistake. I think it's actually okay to process the whole list every time you decide, jobs. I was talking about, usually jobs are small, like we try to optimize the system so we can have small jobs. And this system doesn't need small jobs. I mean, I don't know how long these jobs take. I have no data, never looked at it. But the ProcGen is working on a substantial amount of stuff, and the mesh is a huge amount of stuff. And to the extent that I think it's okay that they have to do some processing here. The question is, how much processing do they have to do, given that the lists can be very long. But the observation is that the list is in priority order, and there's only so many worker threads. Like, you know, a single request in here generates a request for 16 chunks. So the worst case is that 15 of those chunks are available and one chunk is ready and one chunk is being processed. And you would go through, analyze that first entry, and you do all this work to realize, no, there's nothing to do there. As soon as that 16th chunk in that thing is finished, that thing is going to just turn into a task to be a mesh item and be skippable much faster. So the only way you can skip past a chunk here, the first chunk, where do we actually go through the chunks? This is the chunks. So the only real way when you get through the first chunk that you don't stop immediately on the first chunk is if some thread out there is already processing this chunk, this mesh request, or contributing to this mesh request. And if we only have like 4 threads, that means you're never actually going to be able to get through more than like 4 items in the list before you find something to do. Unless there's nothing to do. So the list can be huge, but we're going to ignore everything in that list. So we can actually even just still leave this code iterating over the whole list and just change this max built meshes to be much smaller. Now, it needs to be large enough that the renderer is supplying enough data, but we don't need all of it. We can stop at, I don't know what it is currently. It's huge. It's like 1,000 or something. It's in here. Right? Oh no, it's not. It's small. Okay. Well, that's even better. It doesn't need to be big, and it's not big. So I think the idea here was 16 for physics and 16 for the renderer. So that's the most you can get done in one frame, but it's never going to be that fast. It's not building meshes that fast anyway. Now, what I was saying was, I was really talking about sort of the first time through. If a given thread starts processing this list multiple times per frame because it keeps finishing work and having to rescan it, because this list, until the next time this list gets updated by the renderer, it will still have some dead data at the beginning of it that it has to skip through. We could delete that data out of the list, or we can just assume it can skip through it very fast. Currently, we check all the chunks validity, but we could optimize this that, do we delete it? We set its state to, yeah, right, exactly. We changed this state out so it's not. So yeah, I think there can really only ever be like 4 active items in the list. So, yeah, okay, so I'm in the middle of this stuff. I can't currently run it. All right, so I think it actually, in practice, even though the list can be long, it is actually the case that it never will have to process too much data while doing it. So I think what we can do is, as somebody was saying in the chat, because I've set it all up, so it's not very hard to think of. Nobody ever mentioned it. I mean, people probably did ask about why I bothered doing the manager thread, and the idea was just sort of a separation of concerns. Seemed like it would be clear what was going on. It gave me somebody who could access things without semaphores because it's the only one who's allowed to access certain data structures and some things like that. The worker is just computation. They didn't manipulate the caches and the status data and stuff like that. You know, and everybody says don't try to roll your own lockless data structures. Don't even mess with atomics. Just use thread set queues. Just use basic things. And I think what turns out in this one to be the case is that basically everyone wants to take turns being the worker, the manager, and they take turns by taking a semaphore. So there's just going to be one semaphore or mutex, one mutex locking all the data structures at once. If a thread goes into that, it takes the lock, and another thread finishes its work, it can't start doing that until the first thread gets out of that step, because I think that step isn't actually going to take very long, because it's going to bail out as soon as it gets the first thing it doesn't need. Now the problem with all this, it's got to scroll down. The problem with all this is that we're losing a little bit. If I put all this work needs to come out of the renderer thread, because currently it's conflicting. It's not mutex safely. Well, it is inside the requested mesh mutex, so maybe it's kind of safe. Maybe that was the logic. All that basically needs to now move up and live inside the manager logic, and then all this manager logic needs to get run by each thread. So every time a thread finishes a task, it will run all the manager logic, decide what the next task is, and do that task. So the thing is, we do still need to handle. Let me start over. One of the things that this handled cleanly is when the threads run out of work. All the threads run out of work, they go idle. The worker manager is still running every frame when the renderer updates it and tells it to go. It gave us an authority on that. And if this thing finds no more work to do, it doesn't wake up the workers. And if it finds more work to do, it wakes up the workers. So in the new scheme, without a manager thread, when the renderer takes these things over, it's going to just have to wake up some worker thread. So I think it actually, in practice, even though the list can be long, it is actually the case that it never will have to process too much data while doing it. So I think what we can do is, as somebody was saying in the chat, because I've set it all up, so it's not very hard to think of. Nobody ever mentioned it. I mean, people probably did ask about why I bothered doing the manager thread, and the idea was just sort of a separation of concerns. Seemed like it would be clear what was going on. It gave me somebody who could access things without semaphores, because it's the only one who's allowed to access certain data structures and some things like that. The worker is just computation. They didn't manipulate the caches and the status data and stuff like that. And everybody says don't try to roll your own lockless data structures, don't even mess with atomics, just use thread set queues, just use basic things. And I think what turns out in this one to be the case is that basically everyone wants to take turns being the manager, and they take turns by taking a semaphore. So there's just going to be one semaphore or mutex, one mutex locking all the data structures at once. If a thread goes into that, it takes the lock, and another thread finishes its work, it can't start doing that until the first thread gets out of that step, because I think that step isn't actually going to take very long, because it's going to bail out as soon as it gets the first thing it doesn't need. Now the problem with all this, it's got to scroll down. The problem with all this is that we're losing. So in the new scheme, without a manager thread, when the renderer takes these things over, it's going to just have to wake up some worker thread who's going to have to check if there's work to do. And there might be no worker thread to wake up. So that's going to be some complexity that I haven't figured out. It was not my priority to think about that stuff. And all this stuff with handling this work is already in progress, clean it up, that's down here. Like, I don't know if that can work exactly the same as it did here, or if it's going to need to do something different. Why is it not in JavaScript? Is that a serious question, or is that why is it not in Why is it not in JavaScript? Is that a serious question, or is that a troll? He hasn't answered since somebody gave him an answer, but I don't think you could do this very well in JavaScript. I mean, I don't think Minecraft does this very well in Java. I think Java is not a good choice for a game like this. And Notch has pointed out that he didn't know when he was writing Minecraft that he was writing Minecraft. He had no idea that it was going to be a $2 billion game. Or $1 billion game, I guess it is. Company sold for $2 billion. I think the game is only at $1 billion. And maybe, I mean, probably not. He probably wouldn't have changed languages if he had known. But you could kind of go, if this is the game that's going to be the Minecraft, but he hasn't answered since somebody gave him an answer. But I don't think you could do this very well in JavaScript. I mean, I don't think Minecraft does this very well in Java. I think Java is not a good choice for a game like this. And Notch has pointed out that he didn't know when he was writing Minecraft that he was writing Minecraft. He had no idea that it was going to be a $2 billion game. Or $1 billion game, I guess it is. Company sold for $2 billion. I think the game is only at. Notch has pointed out Java is not a good JavaScript. I mean, I don't think Minecraft does. I don't think you could do this very well in JavaScript. I mean, I don't think Minecraft does this very well in Java. I think Java is not a good choice for a game like this. And Notch has pointed out that he didn't know when he was writing Minecraft that he was writing Minecraft. He had no idea that it was going to be a $2 billion game. Or $1 billion game, I guess it is. Company sold for $2 billion. I think the game is only at $1 billion. And maybe, I mean, probably not. He probably wouldn't have changed languages if he had known. But you could kind of go, if this is the game that's going to be the ambassador to the non-gaming world, right? Like lots of people who play Minecraft and nothing else, much like World of Warcraft used to be, maybe. Maybe it would be nice if that ambassador was not quite so janky. And I don't want to bash on Minecraft too hard, if for no other reason that my professional product, UI product, is used in the Pocket Edition. So I probably shouldn't say nasty things about Minecraft, but it is pretty clearly janky. I guess the Pocket Edition isn't Java, though. I wonder what they did. How are we running out of memory? We didn't do anything. We just moved. I wonder what they did. The edition isn't Java, though. I wonder janky. I guess the Pocket Edition isn't Java, though. I wonder what they did. How are we running out of memory? We didn't do anything. We just moved back and forth. And the problem is when it runs. And the problem is, when it runs out of memory, it's too late to, because I have to run all the code to shut the system down to be able to get the useful. Maybe it's just fragmenting. I am running on a, maybe I'm leaking OpenGL memory. Where's that? That's in voxel render. We added for the picker, we added this instance rendering stuff. Maybe I'm creating vertex buffers and not freeing them or something. Texture buffers. No, I just have two globals that I keep rebinding. I don't recreate them, I assume. That's building the storage. Where do I build the create picker buffers? It's in part of it. Yeah, okay. I'm not running that stuff. So I don't think it should be OpenGL stuff. I don't know. So yeah, I don't know what the Pocket Edition is like. Maybe it is less janky. So, and that's Java that like has a real static typing and stuff like that that really allows a little more performance, even though the OpenGL interface is a little limited. I don't know if has Java been updated. Do they get to use more advanced OpenGL stuff, or do they still have to use display lists as their only acceleration functionality? Like, sure, this thing outperforms Minecraft hugely, but that's not like the constraints that Minecraft has as a Java app are huge. And I'm not talking shit here. Like, the SB voxel render demo thing, it's the K-view, is a Minecraft renderer that the view distance is set to 1200 or something like that, and I'm running in 32-bit, right? In Minecraft, you're limited to 256 in 32-bit and 512 in 64-bit, and in that thing set at 1200, and it can keep up as you move around without you seeing any stuff popping in, like. The whole just-in-time compiler and garbage collection, just-in-time compiler can be just as fast as ahead of compilation, and garbage collection can be just as fast as manual memory management. May be true in some circumstances, but they're not true in the Minecraft circumstance. Okay. Have I finished explaining what the plan? Okay. Have I finished explaining what the plan is? I think I finished explaining what the plan is. So then the question is, why is it simple? And the answer to why it's simple, I still have to find out why I'm running out of memory. And the answer to why it's simple is because I think all of the mesh chunk status logic is unchanged. All that's changing is the threads and thread-specific handling, the mutexes and stuff like that. I think all of these pieces of code, these blocks of code, like the worker manager's code here, I can just preserve as is and just push this into a function and call it from each thread. I think that all will be possible. Because there is nobody to wake up from the worker manager, there will be estimated complexity. I'll have to have, when a thread runs out of work to do, it sets some kind of flag, puts itself on a wake up queue. And when the renderer comes through and swaps in the new set of data, it wakes up. If there is anybody in that queue, it wakes them up, wakes up the first one. And that first one goes and scans the list and sees if it has work to do. And if it does have work to do, it starts that work and wakes up the next one who repeats. So I think though most of the code that's not threads, most of the code that's not thread specific can be kept, and I just have to write new, use one semaphore, one mutex everywhere, for the most part, and then I'll have to fill in those wake up details. That may add some more complexity back to it, to the simple thing. And all that stuff I just said about Java is me talking it out my ass. I have no actual experience using it. Maybe Minecraft itself is just poorly coded, right, or something like that. To the degree that it is a janky kind of piece of crap. I love it. Don't get me wrong. I just think it's a bad ambassador. TCP/IP networking, so that like before I succumbed to trying to run Minecraft, I watched lots of Let's Plays, and you would occasionally see these streamers playing, competitive UHC or whatever, and they have crazy network glitches where somebody just isn't moving, and then they suddenly warp all through the world like crazy, and that's TCP happening to you. So let me catch up on what's happening in chat since I was replying to that. Yeah, Pocket Edition is C++. Pocket Edition is C. Yeah, Pocket Edition is C++. And the Win 10, yeah, that seemed like it was a port back of the Pocket Minecraft, but it's so less featurey, and you lose all the mods and stuff. There were 6. Oh, it's a lot. Okay, so that's not a question. There were 6. Oh, it's a lot. Okay, so that's not a question for me. There were 6. Oh, it's a lot. I'm talking about programming for cars and planes. I'm talking about programming for cars and planes. Could I do the wake up logic with auto reset events? Probably. I try to avoid learning more threading primitives, which may be wrong. Reset events. Probably the wake up logic with. Could I do the wake up logic with auto reset events? Probably. I try to avoid learning more threading primitives, which may be wrong. Like maybe threading primitives, picking the right threading primitive for the task. Will simplify your life a lot, but it's just like more stuff to know. And let's see if SDL has. Oh no, that's not the right kind of event. I want a thread event, not a. That's an event. SDL signals, maybe. What would they be called in? No. Yeah, I don't know what to look for. I guess SDL threads. Just look at what they're listed. Oh, this is 1.2, but okay. Condition variables? What is an auto reset event in these terms? I don't know. Oh, well, there's C# one. What's the auto reset part of it? I assume that's one of those signals that you can't miss kind of thing. I don't even remember what the circumstances are that leads to signals being missed. I forget because I don't do enough thread programming, because I don't like to do thread programming and avoid it like the plague. Iggy uses a background thread for its sound mixing, and I just used atomics for most of the communication between the threads, because it was like a pretty narrow set of things it needed to do. It's mostly a producer-consumer kind of relationship, and so you could actually just use a no atomic queue even in theory, but so I did it with atomics, and it's not even stateful. Like, it doesn't even need, like, when you write stuff with atomics, you usually want to sort of write a state machine. You're not listening to code. You want to whiteboard out a state machine and make sure that it's explicit what states the thing can be in. And this was so simple at doing it. And that's pretty much it. Like, I avoid thread programming that much because I think I've talked about this before. I'm a pretty good programmer, and what that involves, I'm a pretty good programmer, and talked about this before. Much it. Like, I avoid thread programming that's nothing can be in. And this was so simple at doing it. And that's pretty much it. Like, I avoid thread programming that much because I think I've talked about this before. I'm a pretty good programmer, and what that involves is sort of an understanding of how the machine evolves over time. And you have this machine state, and you've abstracted it in lots of ways. You're not thinking about the individual bytes, but sometimes you are. And each instruction or each function or each whatever evolves that machine in a usually relatively simple way. If it's an increment, it's some memory that's being done whatever. And if it's step your simulation, it's doing a ton of stuff in terms of the memory traffic. But I've talked about this before. I'm a pretty good programmer, and what that involves is sort of an understanding of how the machine evolves over time. And you have this machine's ton of stuff in terms of the memory traffic, but it's doing this conceptually simple thing of taking the simulation state of all of your objects and advancing them to the next simulated state. And there needs to be I need to come up with a good diagram for this, but in terms of what that means in terms of understanding code is what you have to understand is these incremental steps. They're very well defined, and what you need to reason about are you're in this state and you're taking these incremental steps. And when you do multi-threading, that's all out the window. I mean, obviously you use primitives that avoid it going out the window as much as possible, but to the extent that you're doing shared memory multi-threading, your state is your state of all of your threads at once. And your state can evolve from the perspective of one thread in a very complicated way. From the perspective of all the threads, it's like, well, each one individually evolving. And you could think of each one as just taking a simple step. But you have to think about all possible states every other thing can be in as it takes its one step. All the other threads can be in any state, or some subset of states that are implied by the current status of the mutexes or the whatever, and reason about that. And to me, it's just a very different kind of reasoning. It's very bug prone. It's not something you can really wrap your head around. In other words, you have to rely on the threading primitives doing their work to introduce, they're not even leaky abstractions, to introduce these abstractions and sort of reason about those abstractions abstractly. Instead of reasoning, what feels like a very concrete reasoning to me in the single-threaded case. That's my really hand-wavy and bad way to try to explain it. What to me, mentally, my experience of actually trying to think about it, like, sometimes I program very fast and people are impressed by that. Or even yesterday when I was racking my brain and stuck, people were kind of impressed. Oh, you're so fast at some things. And as soon as I'm multi-threaded programming, all of that shuts down. I have to think in a sort of different way. Whatever that thing is that lets me go fast is gone with the multi-threaded programming. And I tried to describe it concretely, and I mentally have a kind of conception of the problem, that state problem, that I feel is pretty solid, but I'm not very good at putting it into words. Seeing if people had any comments on what I just said. Like, to me, that is there are experience reasons to be down on multi-threading. That I have more bugs with it. I have, more bad experiences of some kind with it. But my actual reason for disliking it is because the process of reasoning doesn't work the same for me. It just, there is something very simple with the amount of, and maybe this would be different if I had more experience with multi-threaded programming. Maybe it would internalize in the same way, but I'm doubtful of it because of that state problem. Because I have so much experience. Because when I started programming BASIC at age 13 or whatever, it's the same problem, right? It's the break this thing down into recipe steps and follow, and imagine the machine following those steps, and then you can figure out the extractions, and the extractions can be leaky. There can be problems with the abstractions, but most of the time, like, I'm a big fan of abstract data types. You can just reason about them concretely. And in a very disciplined multi-threaded environment, like say one without shared memory, that's all still true. If you're just passing messages between things, this is all still true of each individual thread. You now have to start thinking about what is the message flow. Can I don't even know what the problems, because I'm too used to shared memory stuff, so I'm not sure what the problems are. But presumably you can deadlock, you can get into circumstances where your messages aren't being processed properly, or they're not coming in the right order, or something. And I think that's still a different kind of logic, but maybe a more tractable one, less messy. Maybe it's a little bit like the atomics, where you kind of have to design a little state machine-y thing that's not necessarily explicit, but and be able to reason that yes, this thing can do it. But it still seems like that would be a little messy, depending on how flexible. Like if you have a very simple design where things are, this is a background job, and you send it things and it sends you processed things back, that would always be very straightforward to work with. But if you were trying to do fancier stuff with communications in lots of directions, I still think even without the shared memory, it would still be pretty difficult to reason about. But anyway, so that's the real reason that I'm not a fan of multi-threaded programming, is that it just falls apart for me when I have to reason about anything. And so most of the time I do the multi-threaded programming and ignore that it's multi-threaded and pretend it's single-threaded, and can bring to bear my full experience on it. But it's when I hit those boundaries that everything blows up, and it's a terrible experience, and I'm not happy. And so the whole design of this whole system was thinking about the multi-threading the whole way through, and that was why that was a bad experience. It took me many episodes to get through it. I was very uncomfortable, never was happy with the design, and etc. Okay, so I don't even remember what thing I was answering when I started that. Oh, we were talking about the wake-up logic with auto reset events. So yes, it may be that auto reset events would be the magic thing that does the right thing for what I need for waking up the workers. But if I can't express it in SDL, and I'm always looking at the SDL1 docs, and SDL2 maybe has something better. And so if somebody in the chat says, here's exactly the thing you need, then, I would probably just use it. But I think because you have to kind of round robin between the worker threads, well, you just need somebody to be awake. Yeah, I'm not sure. These docs are so annoying. Come on, get me to the category thread. Okay, there we go. That's what I want. No, it's not, because this doesn't get me to the atomic, or not the mutexes or whatever. Okay. Let's get a mute. No, that's the file. Thread synchronization premise. Jeez. Okay. Yeah. Anyway, yeah. So I've forgotten what like I said, I've forgotten what the case is. What's the case where you need the event that you signal the event and you have to make sure it doesn't get missed? What's the case where it does get missed? I can't even think of that now. Yeah, I don't remember it anyway. So anyway, looking at this, I don't see anything obvious. I've never learned conditional variables, so I don't know what they're really capable of. Maybe they would be the magic sweetness. And if this is working on all SDL platforms, that would be fine. But I think we'll just use a single mutex for the main stuff, and then we'll figure out some kind of logic for waking up waiting threads, which can be done with just a mutex. You just have one thread. It's cleaner with a semaphore, kind of, because it's more the expected semantics with a semaphore. One person goes to sleep on it, another person wakes up on it. You can do the same thing with a mutex, I think, but it's kind of probably more hacky. But even, semaphores, using a semaphore for one thread to wake up another thread is a little bit like simulating having a one item queue, basically. Okay, so what needs to happen here is I'm going to just totally rewrite a lot of the thread logic here. Okay, so what needs to happen here is I'm going to just totally rewrite a lot of the thread logic here. So I don't know if we need the Wait, we don't need the pending ones. I'm not sure if we need the built and finished ones. I think we don't. I think those are used to communicate back from the thread to the manager. So let's check that. Let's check who uses finished gen. Yeah, it's the beginning of here. Here's finished gen. Okay, and then what was the other one? Built meshes. Where do we ever process that? Oh, here it is. Wait, that's adding to the queue. Who's pulling it from the queue? Oh, the renderer task does. Okay, so we still need the built mesh queue. But we only need one queue now. So it might be overkill to have a whole data structure, but we'll keep it around. Maybe we'll need it some other day. So we need the built meshes. Okay, so here's one thing that could happen. What happens if the built meshes fills up? Then here's one thing that could happen. Okay, so here's one thing that could happen. What happens if the built meshes fills up? Then the next time we try to add something to the built meshes, it will be blocked. So that would block the worker thread and it wouldn't be able to make forward progress. It wouldn't be able to process do the manager thread stuff. But by the next frame the renderer will pull them off. So this is fine. It's totally fine. Still need the ref count because the renderer maybe we don't need the ref count mutex, but we're going to assume we do. And the or update mutex is a hack, so I'm going to leave that around. The requested mesh mutex. Okay, we still need something for that, but we're going to make a new one just to make everything more explicit. So now the num mesh workers make a new one just to make something for that, but we're going to we still need something for that, but we're going to make a new one just to make everything more explicit. So now the num mesh workers yeah, and then let's just leave the same count. So this is going to be the swap renderer request mutex, and then there's going to be the manager mutex, which each thread is going to take when it's pretending to be the manager. All right. Wait, are those stars or just? I think they're just this. I think that's the STL style. Let's go up to the top of the file. No, they are stars. Okay. All right, so let's start going through the file in order and see what we need to change. All the gen chunks are the same. Stars. Okay. Alright, so let's start going through the file in order and see what we need to change. All the gen chunks are the same. I think the threading doesn't start till a lot further down. Should put this on a def. What is this doing? Track gen chunks in the global table. So all this logic is unchanged. Pre-caches is unchanged. Now the actual proc gen is unchanged. This should get split up. I should move all the proc gen out to its own file. Putting in the cache is unchanged. Now this putting in the cache should happen as part of the manager logic, though, right? So we might want to like have an assert, and we need thread locals to do that, so maybe not. So this is converted to the physics type. And there's just the mesh generator. Force updates. All of this is unchanged. Build mesh chunk for chord. I think that's the single threaded path. Here we are. I don't know. Was one of these a debug thing and one was an active thing? Like what? I guess the idea was I want 3 threads plus the main thread so that on a quad core machine it's not using hyperthreads at all. They'll get scheduled on their core. I guess that was my idea. Jobs. We still have jobs. We still have tasks. They're just going to set themselves the tasks. Maybe we can refactor that code out eventually. But we shouldn't have max tasks anymore because we aren't going to have queues of tasks. I think we don't need this wakeable waiter anymore. Oh look, I used condition variables to do it. So this is maybe exactly what I need to wake things up. This was designed assuming only one. Yeah, I don't know. It depends on how the condition stuff works. I guess this was designed so more than one thing could try to wait on it. So maybe every thread could go into this. I don't know. We won't worry about it yet. Pending task count. I'm assuming that we don't need that anymore. We do still need the thread safe queue. Just for the output queue. Which I think means we don't need this because we only use the non-blocking one. Okay. This has already filled out the task. Stop worker flag, we'll still want something for that. Get pending task goes away though, so we'll rewrite that. The procgen in use stuff should go live in a different place in the file. Wait. What? Oh, I see. Yeah, this was just a sanity check something early on. I should just delete it. Okay, so I'm moving that. So where's the mesh chunk status? Because it's related to mesh chunk status, so I want to make it live near mesh chunk status. Mesh chunk status, mesh chunk status, mesh chunk status. End of mesh chunk status is right here. So we're copying the procgen status. Okay. Let's back down. Wakeable waiters. Okay, here we are. Mesh worker handler. Okay. Get next built mesh. Right. Yep. Let's go ahead and keep track of the num workers running just because that will be unchanged. Okay, so now they don't get the tasks this way. Let's go ahead and refactor the manager first. Stop manager. It's gonna stop manager. It's gonna have to be rewritten. Let's go ahead and refactor Let's go ahead and refactor the manager first. Stop manager. It's gonna have to be rewritten, but I want some of this code, some ifing it out. C++, no, this is C, which is a lot like C++. C++, no, this is C, which is a lot like C++. It just doesn't have a lot of the things C++ has because I don't really like them or don't need them. What is outstanding procgen used for? That may have to become a global. this only exists to control max proc-gen, which controls putting them in the queue. But that's really kind of unnecessary because the queue will bail itself anyway. So I don't think we need max proc-gen anymore. Which means we don't need outstanding proc-gen. We don't want any of that logic, but we do want this logic. Okay, so void okay, so void get next task. Alright, so here's... Let's just get rid of that because we're going to do different logic. Okay, oh, I've already made this get next task. Okay. Alright, so what do we have to do? So first thing we do, we're going to have to refactor this to actually do the... So let's just... Right, so this goes away because when the proc-gen finishes, we'll have it immediately do this work. So let's move that work to... we can't move that work yet. To do this work at the end of proc-gen. Okay. What was the new name for the new mutex for this? Manager mutex. Okay. Let's make this a little clearer. Through. Yeah, I'm going to tell a story of C story. Yeah, I'm going to tell a story of C story again that I've told before, because people are asking about. They're not even asking me. They're asking about how to learn a library. So C has this very famous, crazy pointer optimization thing that everyone teaches you, where you can do things like this. Optimization thing that crazy pointer optimization. C has this very famous. So C has this very famous crazy pointer optimization thing that everyone teaches you where you can do things like this, which is just magic garbage if you don't know C or C-like language. And in languages that don't have pointers, is Java no point, a quote-unquote no pointer language? Maybe it doesn't make that much sense also. You need pointer arithmetic. That's the thing most languages don't have, which is absolutely true. But, you know, conceptually, this is a part of a string copy where S points to a particular part of the string somewhere in the middle. It's basically pointing to a suffix of a string. So it's pointing to a single character somewhere in the middle of the string. And we're post-incrementing to advance to the next character. And this refers to the contents at the pointer. So when this is on the right here, this is saying get the character that's keep pointing at and advance T. And then we're storing it into the character S is pointing at and advancing. So this is this crazy thing they teach you in C. It's the kind of thing that you should rely on the optimizer to do most of the time for you. You don't need to code things as a pointer walk, you can say s of I equals t sub I, and write it in a loop like this. This is a perfectly reasonable thing. You could also write memcopy. And the classic case where this appears is something like this. And this is an incorrect loop. This is checking that this is not the end of string character. This is actually incorrect as written here because it won't copy the end of string character. So what you need to do to copy the end of string character is you have to go one further. And that's not clear how you do it. And so you can do this equals start t++, because the return value of this whole thing will be the character that got copied. And then you do nothing because you already did the work inside this thing. So this was like back when I learned C, this was sort of like a classic trick. And of course, what you can do is you just write this. Right? There's a function to copy a string, of course. But when I first learned C, I didn't actually know the standard library. And so I would just write loops like this. And this is for class. And I don't remember if I got like penalized for it or whatever, but they knew we didn't know the library. It's a very daunting thing. But string copying is so basic. And yet, because I knew this kind of idiom, it's just, and you, of course, actually write it like that. It's just total obfuscation. And of course, this doesn't even compile nowadays without tons of warnings. Nowadays, you would have to write this as this. If you're doing an assignment like that, it'll warn about the assignment in the thing, because it thinks maybe you meant that. If you just have a single equal like this, the compiler's like, oh, you probably meant equal, because usually if that's what you meant, if you do it. So there's the trick, which is to be explicit about it, and they generally don't warn about this now. You just write 0, and then you can just write this too, potentially. So that might get by a modern compiler, but you obviously just write strict copy. I would never nowadays do this, but when I was first learning, it takes time and it takes experience for you to learn. So anyway, all right, back to the work. Yeah, Java is all pointers, you just can't work. Yeah, Java is all pointers, you just can't see access them. I think the pointer arithmetic is the real thing that's the distinguishing thing. Everything uses pointers under the hood, even if they're not explicit about it. Like that's very clear in John Blow's JAI language, where C has this crazy thing where if you have a pointer to a struct, you do this, and if you have a struct that's not a pointer, you do that. And in JAI, and the top one is equivalent to this. Right, these are the same thing. And in JAI, you just write that whether this one is this means the same thing in both those cases, because it can infer that you must mean it. There's no other thing you could mean. Which is in one case more obfuscatory, because it's doing different things under the hood. The compiler does have to generate different code for those two cases. And it's sort of in the spirit of C to make it explicit, hey, these are doing two different things. But pointer arithmetic is where the metal hits the road with that. Anyway, so we look at the mesh requested by the renderer. What are the possible states here? Oh, it's a header. Okay, yeah. Maybe this could go away. It's either a real request or it's invalid. We invalidate it when we satisfy it. Yeah, the JAI thing I just talked about is syntactic. Yeah, the JAI thing I just talked. Yeah, the JAI thing I just talked about is syntactic sugar to allow you to use the same syntax for the two different semantics. You know, like in C, you know, if you have this. Let me do them in the other order. So if you do this, you can say foo of 5 equals bar of 5, assuming they've filled out foo with something. You use the same syntax for these two, and they do actually generate different code, kind of. However, it's not actually syntactic sugar. It's actually semantic sugar, because bar in this kind of context auto promotes basically to the pointer. So, you know, if we had int star bar p, right, you can just write bar p equals bar. And it's not actually exactly syntactic sugar, right? It's just a semantic rule about what it means to do bar bare by itself, which I guess is kind of syntactic sugar. But anyway, so it turns out that the reason these are the same, though, is not due to sort of a syntactic sugar of this part. It's due to a syntactic sugar of this part, which is kind of weird. And it's hard to call it syntactic sugar because it's so tied up in that. That's an equivalence that always happens, except size of. Yeah, like, right, like when you write this, it can just auto promote this to the pointer, because then it has the same meaning, right? There's actually this classic thing, which is, you know, both of those above can be written as that, right? Those two mean the same thing. So there is just an equivalence of what subscripting means. It just means that. But the difference in these two instructions is how foo is evaluated. Foo is a variable, and it goes and fetches the value of the variable and fills that out, whereas bar is just an address on the stack, basically. Or if it were a static variable, it would just be an address. There would be nothing extra to fetch. So it's all very odd. But like I said, I don't think that's where the metal hits the road. I think it's the pointer arithmetic that's the distinctive, the distinctive thing. So we get the thing, we check its status, we check if it's a fresh rebuild. If it's a fresh distinctive thing. So we get the thing, we check its status, we check if it's a fresh rebuild. If it's a fresh rebuild, we have to rebuild it. Right, do this properly with timestamp steps. That's still what you want to do that at some point, but that doesn't affect any of this stuff. Go through the chunks to see if they're all created. Well, this should be the same. Here we go. If we can start prop gen, then we take our past int. Here's an example of that. And we go to found task, because I need to get out of this whole loop at this point. And maybe break is correct. No, break isn't correct because of these. So you need a named break, and it's just, let's be explicit. We found a task, so let's get out. We don't want to return, because our goal here is to get the next task, and so we could just return with it. But I have to like unlock the semaphore and stuff, and rather than do that inline, I'd rather do that at the end of the function where it's all clear. Okay, so we keep doing this logic. Now we get another thing, and here we go. Boom, time to make another task. So we don't do task T, we do T arrow. Go to found task, and then this path, currently doing it inline. Right, I commented that this was currently doing it inline. Oh, but here we go. Oh, built meshes. I thought it was called finished meshes. Oh, finished gen. Okay, yeah, built mesh. All right, well, so instead of it being inline, it should turn it into a task. But I think I'll wait till I refactor it to do that. So instead, we'll let it continue to do it inline here. And then Yeah, we'll just let it continue to do it here. And then it'll loop. Okay, if it gets to the end of this loop, then it found no work to do. So we'll return 0. Otherwise, we found a task. So we return that we found a task. Okay, and then now we can refactor that to be clear. Let's say result success full success equals default to true. And then if we didn't find one, we'd say success false. If we find a task we go to here, we return a success. Actually, that's a really bad name for that variable. Oh, that's the name of the label, damn it. Okay. So now get next task. I'll move it down to before, and we got to the init, which we already processed. So we've gotten all the way through, except that we skipped updating the mesh worker handler. Okay. Do this work at end of procgen. Okay, so get next task. Okay. Do this work at end of procgen. Okay, so get next task. If get next task returns 0, now it's not time to stop. Now it's time to sleep, waiting for wake up. So yeah, if we use a semaphore, the main thing is we need to be able to query whether the semaphore is 0 or not. So is there a way? Ho-ho! Okay. Maybe that will work. I was going to try to solve this as a separate thing, but let's go ahead and do it. So we do a sem wait on wake up worker sum, and that's it. So we could do that inside of get next task. Maybe that would be cleaner. It's just this is already super indented, so it happens here. So it could be another loop around here in that, but so we wait till we get a task. Once we get a task, okay, so at some point we need to add this, some kind of way of doing this to exit out so that we can do our memory checking. Which I guess should be get next task should do this. Oh, except I can't, and oh, maybe that will work. Work. I was going to try to solve this as a separate thing, but let's go ahead and do it. So we do a sem wait on wake up worker sem, and that's it. So we could do that inside of get next task. Maybe that would be cleaner. It's just this is already super indented, so it happens here. So it could be another loop around here in that, but so we wait till we get a task. Once we get a task, okay, and so at some point we need to add this, some kind of way of doing this to exit out so that we can do our memory checking. Which I guess should be get next task should do this. Okay. Do this work at end of proc-gen. Okay, so get next task. If get next task returns 0, now it's not time to stop. Now it's time to sleep, waiting for wake up. So yeah, if we use a semaphore, the main thing is we need to be able to query whether the semaphore is 0 or not. So is there a way? Ho-ho! Okay. Maybe. Oh, except I can't exit from here. Maybe that. Okay. So if we didn't find any work to do, we go to sleep. But somebody else might have already gone to sleep. Yeah, that's fine. So when we get woken up, and we do find some work to do. Yeah, this is that whole thing where this doesn't... If I use a semaphore, I want it to be able to be... It's going to be clearer if I just... maybe that's what the waitable... What was it called? Wakeable waiter. Maybe I need exactly that. I want to be able to signal it even if nobody's waiting for it and have it ignore the signal. But if somebody is waiting for it... Yeah, the semantics of this are really odd. Alright, let me not worry about it. Let me come back to it like I originally planned. Because it's too confusing. Okay, so we get a task. We go through, we generate it. And boom, we want to output it to the built meshes queue, which still exists because that's the queue the render accesses. And if we succeed, we don't wait or wake, we just loop around and try to find another task. Now, if we add to the queue and that's full, we bail on this work and somebody else has to do the work again, and we'll come back around and try to make it do the exact same thing again. Super dumb. But that queue shouldn't fill up. This is just like an emergency circumstance. Okay, if we successfully generate terrain, then we no longer have a queue, so we don't actually have to ref count through the queue. Instead, we have to move up that logic from here. Okay, so what is the actual thing? We have to end progen on that. We have to push the track in the cache. Subtract outstanding progen, but we got rid of that. We have to release to account for the ref counting. These two cancel out. And we don't need the queue update. Okay. And then these have to get changed to dots. And then we don't need FGC anymore at all. Voila. Okay, nice and simple. I want to get rid of validate because that's still okay. If Avner is abusing his mod power, if Avner is abusing his mod powers, let me know. Of course, then he'll probably mute you, and I won't see it. Are you allowed to click on the message and see what got deleted? Yeah, you can. Oh yeah. Okay, that's better. Then he can't abuse them. I was teasing, by the way. I didn't actually think he was abusing his mod powers. Yes, this is exactly the subject matter on which it is appropriate to silence the other side of the subject matter on which. Yes, this is exactly the subject matter on which it is appropriate to silence the other side of the debate, because they are idiots. No, they're not really, but I think most people are better these days, but you should not enter in this discussion without reading this article. And in 70 seconds, I'll add it to the chat so people enter in this discussion without. But you should not enter in this discussion without reading this article. And in 70 seconds, I'll add it to the chat so people have the context. And this article won't necessarily convince you of anything, and I think most people are pretty smart about this now, but one of the issues is just that a lot of things get conflated in this discussion. So I don't actually think you're an idiot for using tabs, but I do think poorly of the choice. Okay, so I assume this is just things aren't declared in the right order anymore because I moved stuff around. Yep. And I want to change the system actually as well. That's something I didn't discuss. Because I want to move this logic that was currently being run in the renderer into the manager logic, even though there's no manager, I want things to work a little differently. Currently, there's two lists at swaps between them, so it's sort of double buffering. And what I actually want to switch it to is there being three lists, sort of like triple buffering. The reason for that is very straightforward. There are two things that want to process the lists. There's a renderer that wants to create them, and there's the background system that wants to consume it. And double buffering is kind of the obvious thing. There, the renderer can fill one out while the thing is processing them. But it actually is what led to this dumb try lock mutex thing, because it can't swap between them if either system is currently processing. So if we have three lists, then there's always a third one. There's one that the renderer is processing, one that the background system is processing, and a spare. And that means the renderer can always swap to the spare safely. So yeah, I don't actually want the tabs versus spaces discussion to get into it, and it's fine if Abner wants to want the tab. So yeah, I don't actually want the tabs versus spaces discussion to get into it. There are two things that want to process the lists. There's a renderer that's not being run in the renderer order anymore because okay, so I assume this is just things aren't declared in the right order anymore because I moved stuff around. Yep. And I want to change the system actually as well. That's something I didn't discuss. Because I want to move this logic that was currently being run in the renderer into the manager logic, even though there's no manager, I want things to work a little differently. Currently, there's two lists at swaps between them, so it's sort of double buffering. And what I actually want to switch it to is there being three lists, sort of like triple buffering. The reason for that is very straightforward. There are two things that want to process the lists. There's a renderer that wants to create them, and there's the background system that wants to consume it. And double buffering is kind of the obvious thing. There, the renderer can fill one out while the thing is processing them. But it actually is what led to this dumb try lock mutex thing, because it can't swap between them if either system is currently processing. So if we have three lists, then there's always a third one. There's one that the renderer is processing, one that the background system is processing, and a spare. And that means the renderer can always swap to the spare safely. So yeah, I don't actually want the tabs versus spaces discussion to get into it, and it's fine if Abner wants to prevent it from happening in the thing, and I just took advantage of the fact that I'm the person on the stream to offer my opinion, but rather than my opinion, I instead offered, here's like some ground rules on the discussion with the JWiz link, and I think that's, sorry for pronouncing JWiz, like that's just how I pronounce it. I don't think anyone else does, but not because I wanted to stake out a position in the tabs versus spaces, but just because I think we should avoid arguing about the things that aren't what anyone actually cares about, or what people should care about, which is what that link advocates, is that there are things we should not, that are not actually relevant to the argument that people keep bringing up. And like I said, I think maybe people are less bad about that these days, but I just wanted to take advantage of my bully pulpit, there's the phrase I was looking for earlier, to offer that little bit of info. Okay, so all this logic needs to happen but none of the locking info. Starvation count, locked. This is not going to be in swap requested meshes anymore. If Abner is abusing his mod powers, let me know. Of course, then he'll probably mute you. Yes, this is exactly the subject matter on which it is appropriate to silence the other side of the debate, because they are idiots. No, they're not really, but I think most people are better these days, but you should not enter in this discussion without reading this article. And in 70 seconds, I'll add it to the chat so people have the context. And this article won't necessarily convince you of anything, and I think most people are pretty smart about this now, but one of the issues is just that a lot of things get conflated in this discussion. So I don't actually think you're an idiot for using tabs, but I do think poorly of the choice. Okay, so I assume this is just things aren't declared. Yes, this is exactly the subject matter on which it is appropriate to silence the other side of the debate, because they are idiots. No, they're not really, but I think most people are better these days, but you should not enter in this discussion without reading this article. And in 70 seconds, I'll add it to the chat so people have the context. And this article won't necessarily convince you of anything, and I think most people are pretty smart about this now, but one of the issues is just that a lot of things get conflated in this discussion. So I don't actually think you're an idiot for using tabs, but I do think poorly of the choice. Okay, so I assume this is just things aren't declared in the, okay, so I assume this is just things aren't declared in the right order anymore because I moved stuff around. Yep. And I want to change the system actually as well. That's something I didn't discuss. Because I want to move this logic that was currently being run in the renderer into the manager logic, even though there's no manager. I want things to work a little differently. Currently, there's two lists at swaps between them, so it's sort of double buffering. And what I actually want to switch it to is there being three lists, sort of like triple buffering. The reason for that is very straightforward. There are two things. Okay, so I assume this is just things aren't declared in the right order anymore because I moved stuff around. Yep.